notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos. Section 1, Number Theory and Computation. All 33 of those videos have been published on YouTube in their entirety. Section 2, Consumer Arithmetic. All 12 of those videos have been published on YouTube in their entirety. Section 3, Sets. All 6 of these videos have been published on YouTube in their entirety. So all 51 of those videos have been published in their entirety on YouTube. Please make good use of them. We are now at section 4, measurement. This is the third of 16 videos, and I was hoping to have those completed by the end of December 2024, but I'm running a little late with that schedule. After that, we will continue with statistics, January 2025, by end of January 2025, hopefully. Then algebra, February 2025. Relations, functions, and graphs by the end of March 2025. Then geometry and trigonometry by the end of April 2025. And finally, vectors and matrices, hopefully by mid-May 2025, so that all the objectives in this syllabus should be completed by May 2025. Just a reminder again that I have divided section 1 into 33 videos, and they are all available in their entirety on YouTube, especially since this section, section 1, forms the foundation on which the rest of the syllabus is based. How well you can handle this section will predict how well you will do with the rest of the syllabus. So please make sure that you view all these 33 videos as shown on the left here, because they form the foundation of the rest of the syllabus. Additional reminder, if you don't already know the 2 to 12 times tables, you need to learn that, especially since calculators are not allowed in paper 1. So as I said, all 12 of these videos from section 2 have been published on YouTube in their entirety, all 12. And then from section 3, all 6 of these videos have been published in their entirety on YouTube. We are now on section 4, measurement. This first video here, which deals with conversion of units of length, that has been published on YouTube in its entirety. This video 2 here will only be partially published on YouTube. And now we are at objective 2 in section 4, SI units, and this comprises the third video in this section. This is a print screen from the syllabus. We finished with objective 1. We are now at objective 2. Notice we are referred back to section 1, specific objective 8. Convert units of length, mass, area, volume, and capacity. And then we have these 5 more objectives here. And finally, those 6 more, which would give us 15 objectives for this section. If you find this video useful and interesting, please like and share. Like, and share. You may even consider subscribing to this channel. So, Objective 4.2, use appropriate SI units for the measurement of area, volume, and capacity, mass, temperature, and time, and other derived quantities. So we are here, Objective 2. Now notice here they say SI unit. But then in Section 1, Objective 8, the objective we were referred back to says in the metric scale. Now, this is all the measurement examples given in the syllabus. Time this way, measurement with margin of error, and meters per second or meters per second. Those are all the examples from page 7 in the syllabus. So two things to note about this objective here. One, it is somewhat misleading as mass, temperature, and time are not derived quantities, but rather fundamental quantities. But the way you read this objective, it looks like those are derived quantities. It says, and other derived quantities. Area is a derived quantity, so is volume, so is capacity. Mass is not, neither is temperature nor time. Those are fundamental quantities. So be careful with that. And two, it refers you back to Section 1, Objective 8, but that objective deals with the metric system, not the SI system of measurement, which says convert from one set of units to another. This is the Objective 8, and then it deals with metric scale here. Having said that, the metric system is somewhat similar to the SI system, as we will see in the next slide. So many of the same principles apply. One historical note: the International System of Units, internationally known by the abbreviation SI from the French Système International d'Unité, is the modern form of the metric system and the world's most widely used system of measurement. Now, I know I said International System of Units, but if we use this French name, S and I, Système International, that's where the SI comes from, SI. And the SI is the latest system, and it's an upgrade of the metric system. So I am not too sure why CXC says you need to know the metric system and the SI system, but we will try to do our best to deal with both of them. Now, if you look at the metric system, length is the meter, and so is in the SI system, length is the meter. Mass in the metric system is the gram, but in the SI system, it's the kilogram. Not that it makes much difference since we're dealing with indices of 10. Time in seconds for the metric system, and in the SI system, seconds as well. Now, temperature is one of the major differences. In the metric system, you have degrees Celsius written this way, and in the SI system, it's degree Kelvin, or some people just say kelvins, written with an uppercase A. Electric current is the same thing, ampere, and luminous intensity, candela, CD, and amount of substance, mole, MOL. So we will mix and match them as we go along. We'll do some metric. We have done a lot of metric already. What we have already done, we will not do over. And the new things in SI system, we will look at those. Derived quantities are made up of fundamental quantities. Now remember, what you see here are the fundamental quantities on the left there. So if you multiply, if you find the area, you're multiplying meter by meter and you get square meter. That is a derived quantity from the fundamental quantity meter. If you find volume, you multiply meter by meter by meter, and you get cubic meters. Cubic meter would be a derived quantity from the fundamental quantity meter. And if you say speed is so many meters per second, then meters per second is a derived quantity from two fundamental quantities, which would be length and time, meters per second, required by CSEC, but of which you will hear and see in common usage, especially in the United States, where reference is made to temperature. That is the Fahrenheit temperature scale. So if you look on the left here, you have a thermometer that shows the Fahrenheit temperature scale. In the middle here, one that shows the Celsius, and on the far right here, one that shows the Kelvin temperature scale. The Fahrenheit is an old system used only in the US today, and it is not required by CSEC. This is just for your information. This one here in the middle is the metric, and this one over here is SI. In the Fahrenheit scale, water freezes at 32 degrees Fahrenheit and boils at 212 degrees Fahrenheit. So between freezing and boiling water, you have 180 degrees Fahrenheit. And there is a way to convert that, but we are not dealing with conversion right now. In the Celsius scale, water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. And so from 0 to 100, you have 100 degrees Celsius. And in the Kelvin scale, water freezes at 273 degrees Kelvin and boils at 373 degrees Kelvin. So from freezing water to boiling water, you have this same 100 degrees difference as you have for Celsius. If we take a second look at that, except now we have Fahrenheit on the far right, Kelvin on the far left, Celsius is still in the middle. Water freezes, 273 degrees Kelvin, 0 degrees Celsius, 32 degrees Fahrenheit. Water boils at 373 Kelvins, 100 degrees Celsius, and 212 degrees Fahrenheit. And human body temperature, just for reference, in the Kelvin scale is 310, in Celsius is 37, and in Fahrenheit, this drawing here has 98 actually. If we take that 37 over there, we multiply by 9 over 5 and then add 32, we actually get 98.6 degrees Fahrenheit. And if you make a break here and come further down, we find absolute zero. The coldest temperature we can think of or ever achieve is 0 Kelvin. That is negative 273 degrees Celsius and also negative 459 degrees Fahrenheit. That temperature is known as absolute zero. So we will concentrate on Kelvin and Celsius, between the metric and the SI. Consider the shipping barrel shown in the diagram at right. Calculate its capacity. So now we are dealing with capacity. We already talked about area and volume. If its internal diameter is 64 centimeters, its internal height is 1.25 meter. State your answer in cubic meters, correct to 2 decimal places. So this is the shipping barrel. The internal diameter here is 64 centimeters and the height is 1.25 meters. So the volume of a cylinder is pi r square, that would be the area of this top here. And then you multiply that by the height, which is this. So pi r square h. The diameter is 64 centimeters, so the radius r will be 64 divided by 2. So we get 0.32 meter. And the height is 1.25 meter. You substitute the numbers in the equation, and you get 0.40212 cubic meter.